is the last graph we're going to talk about. And just like we did with the previous graphs, we're going to graph them. We're going to graph an example using Excel. So make sure you have your laptop. And we're also able to analyze them. And there's a couple of sort of vocabulary terms that go with this type of graph that you should be familiar from, like science, from grade 9 and grade 10. Okay, so a line graph is for continuous data, whereas bar graphs and circle graphs were for discrete data. And basically, line graphs are good because they show trends through a series of points and segments connecting all those points. So when you look at a line graph, which I'm sure you're all familiar with, like I said, it's easy to describe sort of what's happening. Like if I said here, okay, so this is the temperature on July 13th. I mean, what's happening? Yeah, so it's starts off cool, reach peak temperature around noon, a little after noon, maybe towards 1 o'clock, and then comes down cooler, not quite as cool in the morning by nighttime. And you can just sort of see that by how this goes. And yeah, you are right. Yeah. It would be more towards 2 o'clock than it would be towards 1 o'clock. Okay. Now, in a line graph, we've got the horizontal axis. In this case, it's time of day. And the vertical axis is the temperature. Both of these things we call variables. And we refer to each of them either as an independent variable or a dependent variable. So how do you recognize which one is which? Well, first of all, any good line graph, the independent variable is always on the horizontal axis. The dependent variable is on the vertical axis. Because if you think about it, and we actually did this in grade 10 math, we talked about the independent variable being x, which is horizontal, and the dependent being y, which is vertical. So the dependent variable we get because it depends on what's happening with the independent variable. So the dependent variable is changing based on what's happening to the independent variable. So you have to be able to recognize in a situation which one's independent and which one's dependent. So here's just a couple of examples. So the distance you are from home compared to the amount of time you've spent driving. Which one would be independent and which one would be dependent? So it's like the independent one is the one that we can control. And the dependent one depends on, well, it depends on what's happening with the other variable. Yes, therefore the dependent would be the distance. Because like you decide how much you're going to drive, and the distance changes depending on how much you decide to drive. Okay, so yes, time driving would be the independent here. Distance from home would be the dependent. The number of pizzas you need for a party compared to the number of people at the party. What's that? Pizzas depend on the number of people. So the independent is going to be on the number of people, and that dictates how many pizzas we're going to need. the amount of time spent doing homework compared to the amount of homework you have left to do. And dependent would be, right. Oh, no, that's right. Yeah, times, yeah. Time doing homework. And I'll just put H/W for homework. And that will dictate the amount of homework left. Notice that kind of, the way that it's phrased doesn't necessarily mean that the independent one's coming first and the dependent one's coming second. Got to think about the age of a person compared to their height. Age would be independent. Height would be dependent, yes. Because your height will depend basically on how old you are. Right, in general. There are always exceptions, of course, that we've seen. Okay, so that's something that we've got to be familiar with when we do line graphs, is knowing which ones are independent and dependent variables, and then setting them up on the line graph. Independent always goes on the horizontal, dependent goes on the vertical. So creating a line graph with Excel. Okay. So if you can pull out your laptop, please, and we'll just whip through one. It's very, very similar to the previous graphs. You guys know how to do titles. You know how to title a horizontal axis. You know how to title a vertical axis. Really, it's just a matter of knowing which graph to choose when you want to represent a line graph, because there's a bunch of different ones. So this one, we've got the thickness of the ice on Lake Winnipeg compared to the month of the year. So thickness would be our dependent, because how thick the ice will be depends on what time of year it is. And you can see we don't do every month. We just start from October when there could be ice, and end in June where there could be ice. But we see in these two cases, there isn't. So all you want to do is enter the data in your cells, in column A and column B, exactly as you see here. So the months, and then the corresponding numbers. Just put the numbers, don't put the units. Keep moving on. So once you've got all that data entered, really just the big thing here is, like I said, deciding which graph to choose. So highlight all your data, go to insert, go to the graph pictures, go to the one just below the bar graph that has two line graphs, okay? And then choose this one, the fourth one, the ones that have dots on them and that cross each other. That'll get you the line graph you want. It's Ms. Greenhill. No, it's not COVID. So you should have something like this. Yeah, you can just delete the chart and then switch your data. So here you should have this, your basic one. Change your chart title to thickness of ice on Lake Winnipeg or something along that line. Put labels, month for horizontal and thickness of ice for vertical, and you've got a completed line graph. And you can see a trend here just by looking at it, kind of an obvious trend that as we get more into the winter months, the thickness on the ice increases until it reaches maximum thickness in January and February, and then it starts to slowly get thinner and thinner and thinner until it's all gone. Okay. I mean, a lot of these you can sort of, it's kind of obvious common sense what happens, but you can see the graph shows us that too. And that we do get a time where it's staying at a certain thickness for a certain period of time, basically for 2 months, January and February. And then I would suggest that once you've got all that done, save it under that folder, lesson 2.4 line graph. So hopefully you've got at least 4 files in that folder. Lesson 2.1, you've got the circle graph we did together. 2.2, you've got the bar graph we did together. 2.3, you've got the histogram we did together. And 2.4, you've got the line graph that we just did.
I'm learning more ways to make it look good. I've got rounded corners now. Pink and the background is like a nice light purple.
There you go.
Yeah.
Very nice.
Working on it.
You could do 3-dimensional. Although I find though that some of those 3-dimensional ones, the bar graph, the histogram, and the line graphs, they're actually hard to read. I think it's the second one you choose.
Well,
If you go back to,
just change it, like if I go into that.
go back to, yeah. Or no, sorry, go
Small one.
insert.
That one.
Go back to the line graphs and try
Oh,
that
that's
one.
weird.
Just see what it does. Yeah, see, it's kind of, yeah. And it's a little bit hard to read because it tries to show it 3D.
Yeah.
Not the greatest. Okay. So again, that gives you an idea of what a line graph looks like. And of course, yes, as you were doing, you can just play around with it, change background color, change line colors. I mean, you can change the number of grids that you see on it, all sorts of things that you could change to it.
To make
Yeah.
borders around the titles.
Oh yeah.
It's like really exciting.
Okay. So just like we can do, and you've done questions where you've been given a graph and you've been asked information about it, we can do that with line graphs. But there are a couple of specific words that we use when we're describing line graphs, or especially when we're trying to pull information from line graphs. Okay. So here we have an example Nice thing is I was able to make all of these by Excel, these line graphs. So I got my good practice too. Manager at a car factory wanted to compare the number of workers present to the number of cars produced. He recorded the data for 1 week, used the results to create a line graph as shown below. Okay, so we're not exactly sure, like, well, we assume it was Monday to Friday, and we don't know if this was Monday, Tuesday, Wednesday, Thursday, Friday. This person just basically, I guess, if there were, took the lowest number of workers, put them first, then the second lowest, then third lowest, and then eventually to the highest. But ended up with this, okay? So before we get into anything else, so if I said, what if 80 workers were at the factory? How many cars were produced? 12. Pretty easy, that's along the grid lines, you just go up 80. And 12, okay? But now, what if it wasn't a dot that was on, or that was given? So what if, how many cars, like based on this line graph, how many cars would you expect to be produced if 100 workers? 100 workers, looks like we're about halfway, and we don't want to say half a car. So we would say 15 cars. When you are asked to find something within the graph that you're given, that is called interpolation. Okay, so if I asked you, like if I said, 60 workers, about how many cars? Well, that's interpolation because it's within the graph. But if I asked you 120 workers, that's outside the graph. That's something else. Okay, so this is referred to as interpolation. Interpolation. Estimating values within the range of data given. Not sure why I spread out that A there. If we are asked to estimate values outside the range of data that we're given, that's called extrapolation, which part B is an example of. 40 workers were present. So we're going to have to decide, okay, how is this graph moving? Would it be reasonable to say it does this? Why not? Yeah, it's kind of steadily increasing, not quite here, but pretty steady here. So this wouldn't be a good way to do it. Probably what we could do the best way is just continue this straight line that's happening here. And it looks like we're going to get 40 workers as about 6 cars. And that's an extrapolation. Okay. So 40 workers would be 6 cars. Because it's outside the range of data, we are doing an extrapolation. Estimating values outside the range of data. Given. Sometimes when you are asked to extrapolate, and you hope maybe remember this from AP Stats, you'll get an answer that doesn't make sense. Sometimes extrapolation is not useful. So for example, like if we kept that graph going, if we kept this trend line going, we might get down to about there, which is what? Number of workers, maybe 6 or so, okay? Well, if we try to say, okay, at 6 workers, how many cars are produced? 0. Well, that really doesn't make much sense. You got to figure they're going to produce something, okay? And the same thing, you're going to reach a point where you just can't fit that number of workers in a factory. Like if you say how many cars will be produced with 2,000 workers, you probably won't know because you probably can't fit 2,000 workers in this factory. At least comfortably. So that's something that we can read from line graphs. So line graphs also involves interpolation and extrapolation. And finally, just what we've done with all the graphs that we've looked at, and so it'll be 4 graphs we will have looked at, basically 2 for discrete, 2 for continuous. We have our advantages and disadvantages. So an advantage, like with bar graphs, easy to compare more than one set of data. So even though we didn't do one, you could have double line graphs, just like double bar graphs. And as I write, I'm writing bar as I say it, and I should be writing line. So if we want to compare more than one set of data, bar graphs and line graphs are the best. Okay. Line graphs are quite good at making relationships clear. Or instead of relationships, we could even say trends. Clear. You know, they're either increasing, decreasing, or perhaps both, or perhaps they're just fluctuating, much like stock market graphs do. Okay, a lot of times they'll fluctuate based on if the market does well, up we go, down we go, up we go, maybe not as much, etc. Okay. And any data that doesn't fit the trend will be obvious. Something that we refer to in stats as an outlier, or something weird has happened. You know, like what if we went back to that worker example and at 80 workers, they were able to produce, say, 24 cars. I mean, what happened there? Because it was just sort of climbing nicely and then it went like that, came back and then started climbing nicely. Something must have gone on there. I'll leave it up to you to speculate. Disadvantages. Okay. if the data is not a straight line, or roughly a straight line, extrapolation is difficult. So if it's fluctuating, it could be hard to predict results outside the range of data that we're given. We could still go inside interpolation, but extrapolation could become difficult. Okay. And line graphs can use discrete data, even though it's better for continuous. But sometimes it may not make sense. So we could use, like that previous example with the number of workers, that's really discrete data because you can't have part of a worker. Although, some of the graph wouldn't make sense. You would say, well, like, how many cars could 40.75 workers produce? Well, that's not a question that's reasonable to answer. Okay. So essentially, we've got discrete and continuous data are two main types, and we've got different ways of showing them. So each graph has their advantages and their disadvantages. They can be used for discrete and or continuous, okay? So the idea is also to be able to recognize when you're given some data to say, well, what's the best graph that would work here? So if you're given a bunch of continuous data as both variables, you will probably want to be thinking a line graph, okay? Or you may want to take those variables in the independent variable and group them into categories and make a histogram, okay? But if you're seeing something about preferences of people, then you should be thinking, okay, well, now we're looking discrete data. That would be like a circle graph or a bar graph. So hopefully you have an idea of what kind of graph could be used in a situation. So the last thing that we're just going to do, and it's very simple, is we're just going to look at some different graphs because everybody can have different interpretations of graphs. A lot of graphs can be very obvious to everybody, but sometimes people might see something else than somebody else does. Okay, they might look at it a slightly different way, and their opinions might form a graph too. Okay, that's the last thing we're going to look at.